We are going to talk about how to use the program Q.xls to be able to calculate the whip and the cycle time, we also call that the congestion and the delay in the system for different cases. And it looks like this software was written back in 2001 by David Ashley, just to give credit where credit is due. So it's not that big a deal, actually. These are just hidden calculations locked into this Excel sheet. So he's just been able to put in those formulas that we've shown in class. But it's kind of cool because now instead of having to plug and chug it, all you need to do is enter some values for the arrival rate, the service rate, or the service times, number of servers, etc., and you can get back those congestion and delay metrics. Also, you can see there's a little bit more here. We didn't talk about finite queue length, nor did we talk about finite calling populations. That's something finite calling populations, that's not something really common in healthcare. But finite queue length, that is, right? That's, again, capacity constraints. We haven't talked about that, but you can do that if you want to play around with it. Just say, okay, well, here's an MM1 queue, but I'm going to only allow up to 10 people in the system. And you can see how that will affect your congestion and delay metrics. Let's look at the MM1 queue here first. We have, in this example, we put an arrival rate of 9, a service rate of 10 with one server. And you can see what the effects are on the expected length of the queue, the expected number in the system, the expected waiting time in the queue, and the expected waiting time in the system. So if you have, again, a utilization of 90% in an MM1 queue, you would expect that the average number of customers waiting in the queue would be 8.1. Average number of customers in the system is 9, that they would wait 0.9 of an hour in a queue, and that they would wait on average 1 hour in service, right? Or, I'm sorry, 1 hour in the system overall. And we can play with this. Let's pretend we had 2 servers. If we have 2 servers, now my utilization gets cut to 45%, right? And you can see the expected length of the queue now is 0.22. Expected number in the system is 1.12. And then here's my expected waiting time in the queue and expected waiting time in the system. Now, what if I do something like this? Let's go back to 1. But remember, the arrival rate cannot exceed the service rate. But let's try to do it. Let's say we put 12. What's going to happen? Right? It says the arrival rate should not be less than the overall service rate. Because of that, this is just nothing but pure garbage, right? Don't even look at this probability mass function here because it's giving you junk. You can't have negatives, right? So it gives you something here because it's not, you probably should have a command in there to make that go NA or something, but he didn't. So it's okay. You can't do it. You have to have the arrival rate less than the service rate. So excuse me, again, we could have the arrival rate of 12 and a service rate of 10 if we had 2 servers, because now the overall service rate would be 20, right? So my utilization would be 60%, and we could, again, see how that affects my other metrics. Let's go back to the previous where we have 9, 10, and 1. And that, again, is going to be our MM1 queue with a 90% utilization. Now let's contrast that over here to the MG1 queue. Now, with the MG1 queue, we need to specify the arrival rate, which we're going to try to look at the same system. So the arrival rate is going to be equal to 9. We need my service rate. Now, it's telling you over here that your average service rate is 10. And if as I change this, I would see that would change, right? So it's telling me what my average service rate, or it's calculating that for me. But how did I get that 0.1? Well, simply for this MM1 system, I took, the service rate is going to be 1 over the expected service time. So the expected service time is going to be 1 over the service rate. So 1 over 10, that is going to be equal to 0.1. And also we know that if the service time distribution is exponential, then the expected service time, or the average service time, is going to be equal to the standard deviation of service time. So this specification should yield the same results as we had for a 9, 10, and 1 for the MMS system. Well, here we have our 9, 10, and 1. And let's look at my metrics. I have 8.19, 0.91, right? Let's come over here. 0.91, standard deviation of 1, 8.19, 0.91. It's the same thing, right? You can see that I have the same metrics of the congestion and delay when I assume or when I have the standard deviation of the service time set to the average service time itself. But the beauty of an MG1Q is that that's not the case, right? We can actually go through and play with the service time distribution, or the standard deviation of the service time distribution. Note again also that it doesn't ask what the distribution is. It's just MG1 because it's general, right? So I don't need to specify what the distribution is. I just need to specify what the standard deviation of service time is, right? And let's say that the standard deviation of service time is 0.08. What does that do? Well, here we go. We can see it's 0.664, 7.54, 3, and 0.8, right? So we can look and we can see those are my values of the congestion in the queue in the system, waiting time or delay in the queue, delay in the system, if I have a standard deviation of 0.08 on my service time of 0.1. Let's pretend, again, we cut it in half, like we did in some other example, or we did an example in class. And let's take a look at how that affects this stuff right here. Well, look at how it affects it, right? This now is going to be 5.06, 5.96, 5.6, and 6.62. And that, again, is a change from when I had 0.08, right? So these metrics are going down. But also notice, like we've talked about in class, the utilization is not changing. The utilization is 90%. Utilization is 90%. Utilization is 90%, right? The utilization is always 90%. The only thing that's changing is a congestion and delay in the system, which that highlights, like we were talking about in lecture, that as we reduce the standard deviation in the system through process improvement efforts, we're going to be able to see improvements in these metrics as it relates to congestion and delay in the system, or in the waiting lines of my system. And that's it. You know, this spreadsheet Q is just very simple to use. Here again, you can put in the maximum, the finite queue length if you wanted to, right? You can play with this, but it's going to be able to give us these metrics. And this is something you will need to know how to do. So I expect you to be able to know how to use the spreadsheet queue to be able to input the arrival rate, service rate in servers, and or arrival rate, expected service time, standard deviation of service time, and number of servers. So in other words, to be able to use this page and this page to be able to get these metrics of the congestion in the system in queue and the waiting time in the system in queue. Okay, thank you for your time and attention.